All right, this is part 8 of the final exam review for Math 110. We are picking up now with number 32, which says to solve the following inequality and write your answer in interval notation. So we've got 6x squared plus x minus 1 is less than or equal to 0. And let me go ahead and write down number 33, which is the same directions, a cubic polynomial inequality. X cubed minus x squared minus 12x is greater than 0. All right, for both of these, similar to an equation, you want to start off by factoring. So let's see, 6x squared, that is obtainable by either 6x and x or 3x and 2x. And I've found in my experience that the numbers that are closer together tend to work a little more often. So I'm going to start with 3x and 2x. And then to get a -1, you've got to have both of them being 1, but the signs have to be different. Positive times negative gives you negative. So let's see, if we put a plus here and a minus here, and then FOIL that out, we get 2x and -3x, which would give us a -x in the middle, but we want a plus x in the middle, so we need to switch those signs around to a minus and a plus, so that when you FOIL it, you get a minus 2x and a plus 3x to get that plus x in the middle. All right, and then you set each factor equal to 0. Don't try to set them less than or equal to 0, because that doesn't work. Inequalities don't work the same as equations. If a product is less than or equal to 0, that certainly does not mean each factor is less or equal to 0, because that would say negative times negative is negative, which is not true. So what we're going to do is we're going to set each factor equal to 0 to get what will be the endpoints of the intervals. Add 1 to both sides here. 3x equals 1, x equals 1/3. Because when you solve inequalities, your answer is an interval, or 2 intervals. 2x plus 1 equals 0, sometimes 3 intervals. But anyway, not just single values. Here we get 2x equals -1, dividing by 2 gives you x equals -1/2. So what I like to do is go ahead and plot these on a number line. 0's in the middle. Here's 1, here's 2, here's -1, here's -2. So let's locate these numbers. 1/3 is a third of the way from 0 to 1, and -1/2 is half the way between 0 and -1. All right, now also take notice that these places where the where it's equal, where this is equal to 0, are included for this problem because the less than or equal symbol includes equals, right? Less than or equal. So that means we want to include these values. I like to show that with a solid dot to show those endpoints are going to be included. All right, now what we need to do is test each interval. These two points cut the number line into 3 intervals, and so we've got 3 intervals to check to see if they are solutions to the inequality. And I'm going to show you how to do that on your calculator. So if you go to y equals, let's see if I can hold this right without too much of a glare. So you go to your y equals and type in the inequality. So in this case, it's 6x squared plus x minus 1. And we're going to type in the inequality as well. We're going to type in less than or equal to 0. That is under the test menu. So you go second math for the inequalities, and we go to the less than or equal to, option 6, 0. All right, so we've typed in this inequality. What your calculator is going to do is it's going to give it a truth value. It's going to assign it a value of 0 if it's false and 1 if it's true. So if you go to the standard window, zoom standard, option 6, that's usually the best one. If your endpoints are between -10 and 10, then the zoom standard will show what's going on. So you hit enter for that, and what you should see is nothing where it's false because it's 0, which is on the x-axis, and then up at 1 when it's true, and then back down. If you remove your axes, or if you have a calculator that has different colors, you can see it even better. Let me show you. If I go to the format and turn off my axes and go back to graph, now you can see it's false, then it's true, then it's false. Okay, 0, then 1, then 0 again. So let me turn my axes back on. Whoops. And so that x-axis is kind of like our number line. Of course, my number line is scaled a little bit differently. I have it more spread out, but it's in between that we have this inequality is true. So in interval notation, then, remember, you use square brackets to show an endpoint. In this case, -1/2 is included, and then this is the interval from -1/2 to 1/3, another square bracket to show that endpoint is included as well, and that's the answer. For this one, we have a cubic, but fortunately you can factor out an x, and then there's a quadratic left. So still the goal is to factor, and then set each factor equal to 0 to get your endpoints. So here we've got x and x, and 4 and 3, with a 4 negative and the 3 positive is going to give you a minus x in between. So setting each factor equal to 0 gives you 3 endpoints in this case, kind of like you get 3 solutions to a cubic polynomial equation, 3 zeros, 0, 4, and -3. Now these are all not included because this is what we call a strict inequality. Strictly greater than does not include equals. So we do not want to include these values where it's equal. So we've got 0, and I'm going to show an open dot there. 1, 2, 3 is -3, open dot to show that's not included, although we get infinitely close to it. And then 4, not included. So now we actually have 4 intervals to check. One way to do that, as you'll see in your book and your help aids in your online homework, is to test a value. You can pick a number in each interval and test it into the inequality to see if it's true in any version. But again, I like to use the calculator and let the calculator test it for us. So this time I'm going to type in x cubed minus x squared. And I like to type the original inequality in so that we can check to see if it looks like our factors are correct. They should show up as endpoints. All right, I want to test second math. When is that greater than 0? And again, my endpoints are all within -10 to 10, so we should be able to see. Looks like it's true from -3 to 0, and then true again from 4 on. So it's false over here, and it's false in here. So that means true in between these guys, and true from here on up. So that's the open interval, parenthesis, -3 to 0, parentheses used for when the endpoints are not included. And then we use a union symbol to hook intervals together, because there's more than one here. And the other interval is from 4 to infinity, because it keeps on going. And then we always use parentheses around infinity.